this is on the semester test review sheet, and forget what number it is, but it's near the end, and it's number 11 actually. So if we look at this one, a small object, 1 kilogram at point A, and you can see it's moving with 2 meters per second. Point B is 10 meters below point A. Point C is 2 meters above point B. The object has initial velocity 2 meters per second. The track is frictionless except between points C and D, which has a coefficient of friction of 0.5, and answer the following. What is the kinetic energy at point A? So A here, of course, that's 1/2 mv squared, right? And if you just put those numbers in, and I'll put them in this time, I won't put them in every time because you guys can do that. So it's that's 1 kilogram. Now let me put my half in here. I forgot to put my half in. So 1/2 times 1 kilogram times 2 meters per second, and then square that. And if you do that, you're going to get 2 joules. So it's got 2 joules of kinetic energy. That's A. B is what's the potential energy at A? Well, potential energy, of course, gravitational, is what it's talking about, is mgh. That's going to be 1 kilogram times 10 meters per second squared times, how high is it? 10 meters. And when I multiply those three together, I get 100 joules. Okay, and then C, what is the total energy? Well, the total energy is just going to be adding these together. So 100 plus 2 is 102 joules of total energy. That's the total energy. All right. D, what is the total energy at point B? Well, you guys know that energy only changes form, the amount doesn't go away. So if I have 102 joules of energy here, I have 102 joules of energy there. I have at point C, before it starts having friction, 102 joules of energy. Up here I got kinetic and potential. Down here I have only kinetic at B. C, I have again kinetic and potential. I have more kinetic at C and less potential. I have more potential up here and less kinetic. But when added together, it's 102. So this is 102 joules also, because I'll just write this down, because energy is conserved. So you can see energy problems are pretty easy if you just think about them, all right? What is the velocity of the object at point B? Well, all I have to do is say, because it's all kinetic at B, right? No potential. There's no potential because that's where I'm measuring from. In other words, I'm making this a 0, and I'm measuring up from there. 10 meters, 2 meters. So I have no potential at point B. It's all kinetic, so it's going to be, let me write this out. Kinetic energy equals 1/2 mv squared, so 102 joules equals 1/2 times 1 kilogram times v squared. And when I solve for v squared, I'm going to get v equal to 14 meters per second. Okay, EF. Now we're on F. What will be the total energy at point C? I've already answered that. 102 joules. Doesn't change, just the type of energy changes. G. How much PE will it have at C? That's potential energy gravitational. That's going to be mgh, which is 1 kilogram times 10 meters per second squared times 2 meters. And that's going to give me 20 joules when you put that in your calculator. And then how much kinetic energy will it have at point C? Well, let me extend the page one more time. E, F, G, this is H. We know that the total energy always equals the potential plus the kinetic. So therefore, if I know the potential is 20 and I know the total is 102, then I just subtract, right? This is 102 joules equals 20 joules, 20 joules plus kinetic energy. Then kinetic energy has to equal 82 because 82 plus 20 is 102. All right. How much work does friction do on the object between points C and D if the distance between these points is zero point 0.5 meters? And I don't know if you can read this, but the coefficient of friction is 0.52. So what's the only force? Remember work, there's a couple of equations for work. Work equals change in kinetic energy, and work equals force times distance times cosine of theta, right? Well, in this case, I can find a force. The only force on it is frictional force. I find that with the fun equation. Whoops, need an equal sign there. I find that with the fun equation. So what's the normal force on this? Well, it's going to be 10 newtons, right? Because that's the weight. This is a 1 kilogram block. So 0.5 times 10 newtons is going to give me 5 newtons. So I guess I'll go down here and do this. HI. So 5 newtons is my frictional force. I use that fun equation to get that. Again, it's 0.5 times 10. Half of 10 is 5 newtons. That's friction. And the frictional force, sorry, let me erase all the, I'm going to say work equals 5 newtons, force times distance, right? And how far is it? It's 5 meters, or sorry, not 5 meters, 0.5 meters. 0.5 meters, and that tells me I'm going to have 2.5 joules of work done. So let me circle all my answers. That's the amount of work done by friction. That's the kinetic energy at point C. That's the potential energy at point C. That's the total energy at point C. That's the velocity at point B. Total energy at point B. The total energy at point A, the gravitational at point A, potential energy, and the kinetic at point A. And that's how you do one like this, and hope that's helpful.